Hello, everyone. In the last lesson, we learned about the set, reset, positive and negative. In this lesson, we will continue with Task 2, S7-1200 PLC control of the electric retractable door. 3. Multiset and multi-reset. The multiset, also known as the set bit field, is used to set multiple bits starting from a specific address. The multi-reset, also known as the reset bit field, is used to reset multiple bits starting from a specific address. The following diagram illustrates the latter logic for the multiset and multi-reset. Operand 1 specifies the number of bits to be set or reset, and operand 2 specifies the starting address of the bits. Here is an example of using the multiset and multi-reset. In the first network, when the positive of I0.1 is detected, outputs Q0.1, Q0.2, and Q0.3 are set to 1. In the second network, when the negative of I0.2 is detected, outputs Q0.1, Q0.2, and Q0.3 are reset to 0. 4. Edge for scanning the RLO signal. Edge for scanning the RLO signal includes the positive of the RLO signal, P_TRIG, and the negative of the RLO signal, N_TRIG. The positive of the RLO signal, P_TRIG, triggers a signal at the Q output for the duration of one scan cycle when there is an energy flow into the CLK input of the P_TRIG at the rising edge of the flow. The negative of the RLO signal, N_TRIG, triggers a signal at the Q output for the duration of one scan cycle when there is an energy flow into the CLK input of the N_TRIG at the falling edge of the flow. Note that P_TRIG and N_TRIG cannot be placed at the beginning or the end of the instruction list. They must be in the middle. The following diagram illustrates the application of edge for the RLO signal. In program segment 1, when I0.1 is 1 and I0.2 is also 1, the positive of the RLO signal from 0 to 1 flows into the CLK input of the P_TRIG, causing a pulse of 1 scan cycle duration at the Q output, which sets Q0.0. In program segment 2, when I0.1 is 1 and I0.3 is also 1, the negative of the RLO signal from 0 to 1 flows into the CLK input of the N_TRIG, causing a pulse of 1 scan cycle duration at the Q output, which resets Q0.0. Next, we will reinforce the knowledge with a case study. Case 1. Control circuit for the electric retractable door using set and reset task description. The electric retractable door's movement is primarily controlled by the forward and reverse rotation of the motor. Pressing the rise button causes the motor to rotate forward and the electric retractable door to rise. If the fall button is pressed while the door is rising, the door immediately stops rising and begins to fall as the motor reverses. Conversely, if the door is falling and the rise button is pressed, the door immediately stops falling and starts rising as the motor rotates forward. When the door hits the upper limit switch, it stops rising. When it hits the lower limit switch, it stops falling. Pressing the stop button at any time stops the door from rising or falling. Next, let's understand the specific steps for implementing the task. 1. I/O address assignment. Controlling the retractable door involves the motor's forward and reverse rotation, requiring buttons for forward and reverse control. When the retractable door needs to stop, a stop button is required. Additionally, to ensure safety, limit switches must be set to restrict the travel range of the door, with an upper limit switch and a lower limit switch. Thus, 5 input signals are needed, as shown in the table. For outputs, it is necessary to control the raising and lowering of the retractable door. Therefore, 2 outputs are required to control the door's upward and downward movements, respectively. 2. I/O wiring diagram. The diagram shows the I/O wiring for the electric retractable door, connecting the rise, fall, and stop buttons, and the upper and lower limit switches, along with the control relays for the upward and downward movement. 3. Program development. The diagram shows the PLC program for the electric retractable door. According to the task requirements, the following aspects need to be considered when developing the PLC program. 1. Raising control for the electric retractable door. Press the rise button to raise the door, which activates the motor to rotate forward. This sets the forward control relay Q0.0. To prevent the motor from reversing, the reverse control relay Q0.1 is reset to 0. 2. Lowering control for the electric retractable door. Press the fall button to lower the door, which activates the motor to rotate in reverse. This sets the reverse control relay Q0.1 to 1. Similarly, to prevent the motor from rotating forward, the forward control relay Q0.0 is reset to 0. 3. Motor stop control. A. Stop button control. Pressing the stop button stops the retractable door from rising or falling. Consequently, both the forward control relay Q0.0 and the reverse control relay Q0.1 are reset to 0. B. Upper and lower limit switch control. When the door rises and presses the upper limit switch SQ1, the door stops rising, and the forward control relay Q0.0 is reset to 0. When the door lowers and presses the lower limit switch SQ2, the door stops lowering, and the reverse control relay Q0.1 is reset to 0. 4. Program debugging. After developing the program, download it to the Siemens S7-1214 PLC and debug it. 1. Raising and stopping test for the electric retractable door. Press the rise button for the electric retractable door and observe its ascent. During the ascent, press the stop button and check if the door stops rising. Resume the ascent, then press the fall button and observe if the door immediately stops rising and starts descending. After stopping, continue the ascent until the upper limit switch is pressed, and observe if the door automatically stops. If all these steps are successfully completed, the raising and stopping test for the electric retractable door is considered successful. If any step fails, make adjustments and repeat the test until all actions are successfully performed. 2. Lowering and stopping test for the electric retractable door. Press the fall button for the electric retractable door and observe its descent. During the descent, press the stop button and check if the door stops descending. Resume the descent, then press the rise button and observe if the door immediately stops descending and starts ascending. After stopping, continue the descent until the lower limit switch is pressed, and observe if the door automatically stops. If all these steps are successfully completed, the lowering and stopping test for the electric retractable door is considered successful. If any step fails, make adjustments and repeat the test until all actions are successfully performed. Finally, let's review what we've learned. This lesson covered set and reset, positive and negative, multi-set and multi-reset, and edge for scanning the RLO signal. We also created a PLC control program for the electric retractable door using these instructions, providing a deeper understanding of their application. Please complete the following 2 exercises after class to help understand and use these instructions, enhancing your memory. This concludes today's lesson. Thank you for listening.